In this lesson, we are going to talk about arithmetic series, which is just, you could talk about a series is when you add together the terms of a sequence. We could talk about a series or a sum or a partial sum. Series would be if you add them all up without ending, and then a partial sum would be if it was a limited number of terms. So we talked about this yesterday, or in the last lesson, where the nth term, or general form, or explicit form, they all mean the same thing. That's this. We could have a recursive formula. I showed you this in the previous lesson. Today we're going to be using this, the sum of an arithmetic sequence. And a way to memorize this is take the mean of the first and the last, and then multiply it by how many terms there are. And that's how we get a sum. All right, so if we're going to find the sum of n terms, we need to know what n is. We already know the last term. We know the first term and the last term. We just have to know what is n. So we can look for a common difference. 2 minus -5, 7. 9 minus 2 is 7. There's the common difference. Then we can look for n using the nth term of an arithmetic sequence, and we have an is 317, a1 is -5. We're trying to find n, and we know d is 7. Divide by 7. N is 47, and then we can find this sum of 47 terms. First term plus the last term divided by 2. And here we're going to, we already know n is 28. And we just have to find the 28th term, then we'll be able to use the sum formula. So make a table and use the two formulas to answer this question. Pause the video. All right. We need to know the 28th term. If we're looking for a term, then we'll use the nth term formula. We don't know what number that is, but we could call it A28. Let's call that A28. A1 is 27, N is 28, and D 14 minus 27, that's negative 13. 1 minus 14 is negative 13. Common difference is negative 13. So the 28th term is negative 324. Now we can use the sum formula. We want the 28th partial sum. So that's going to be the first term plus the last term divided by 2. And we get that. Okay, so those were similar procedures. Here we have to evaluate using sigma notation, and if we just start with a table, I think that'll help. That will make the problem look more familiar, because if we do a table every time, then they'll all look similar. And we can see the common difference is 2. Here we could do 2 times 23 plus 3. That'll be 49. And 2 times 37 plus 3, 77. So we have all the information that we need, because we have, if we just want to find the sum from 49 to 77, that'll be the first term and the last term. And we have, if we said that's the first term, then that would be the last term. So we have to be careful. We can't just do 37 minus 23. We have to remember that if we did 37 minus 23, that's going to be 14. But we actually have 15 terms, because once we subtract 23, we're not counting it anymore. So we have Sn equals n, a1 plus an over 2. S15 equals 15, 49 plus 77 over 2. So we're just, when we see this notation, we have to think of the sequence starts at 23. So that's where it's starting. That'll be the 1, and then we have 15 terms. And that's 945. All right, same question. I'll pause the video and try that one. So we see the common difference is -2. I guess we don't need that. Here we're looking at n equals 12, negative 2 times 12 plus 57, 33. And then we'll go down to 18, negative 2 times 18 plus 57, 21. If we call this the new first term, 1, then 18 minus 12 is 6, but we're actually going to have 7 terms. So now we know when we use the formula, we have starting at 12 and ending at 18, we have 7 terms. So when we look at this, we have to know that what n is. First term plus the last term over 2. And here we get 189. Find the quadratic model. Well, if we're looking at something that's quadratic, we can also try to find an arithmetic sequence in here. So let's analyze using a table. And one way to think of this would be the quadratic model would be what quadratic equation would you plug a 2 into to get a negative 8? We're trying to make a model that represents all of these values. So we could think of it as n, and then down here we're going to have an squared plus bn plus c. Our goal is to find this model that represents these. Another way to say that would be that we want the nth term of this sequence. But this sequence is not arithmetic. So here we add 6. And now here we add 8. So that's not arithmetic, but what if we looked at this? And now here we have negative 14 plus 6 plus 8 plus 10 plus 12 plus 14. If we look at these numbers as a sequence or a series, then we can see that this is arithmetic. This is called the first difference, and that's called the second difference. So let's look at it like this. Negative 14 plus 6. Negative 14 plus 6 would give you negative 8. And then we'll go plus 8 plus 10 plus 12 plus 14. So here we have a sequence, and the terms of the sequence are generated with this series. We know that this part of the series is arithmetic. This is an arithmetic series, so it could be represented like this. And we could say that this series is equal to negative 14 plus this part, which is right here. And then we can say it's going to be n times the first term, which is 6, plus the nth term. And let's remember what the nth term is. The nth term of an arithmetic sequence, an equals a1 plus n minus 1 times d. So right here is going to be an, because we are looking at this, n, a1 plus an over 2. This part of the formula is this. A1 we know is 6. An we're going to represent with this formula A1, so we have another 6 plus n minus 1, and d, the common difference, is 2. So this is going to be 12 plus 2n minus 2. (10 plus 2n over 2). And this will be 5 plus n. All right. So let's go with that. And we're going to test it because it's probably not totally correct yet. So let's test. Negative 14 plus n, 5 plus n. All right. If we put a 1 in, we're supposed to get negative 14. So let's put a 1 in here. Five plus 1. 6 plus negative 14, that equals negative 8. Let's put a 2 in. 2, 5 plus 2, 7, 14, that gives us 0. So look what's happening. When I put a 1 in, I'm getting what I should get when I put in a 2. When I put a 2 in, I'm getting what I should get when I put in a 3. So we need to adjust the values of n here, and we can just have this be n minus 1. So if you go negative 14, change that to an n minus 1, and change that to an n minus 1. Now when I put a 2 in, it will be like I'm putting in a 1, because if you put a 2 here, you get a 1, which we would get negative 8. So this is the quadratic model. We can say that all of the terms in the sequence can be generated with this, and then this simplifies to be negative 18 plus n squared plus 3n. So here's the summary. We don't have an arithmetic sequence, but if we look at these, the second difference, these numbers are arithmetic. Negative 14 plus 6 plus 8, when you write those out, negative 14 plus 6 plus 8, now we see an arithmetic series, except for the negative 14. So I represent this with the formula, and then just make sure we don't forget about the negative 14. So all of this is negative 14 plus the formula for the sum of an arithmetic series. And we don't know a sub n, but we know a formula for a sub n, then we just simplify down. The next step is testing that. We came up here and tested. When you put in a 1, you get a negative 8, which we didn't want to get. When you put in a 2, you get a 0. We didn't want to get that. So just change all the n's into an n minus 1. All right. Pause the video and do that one the same way. So this is not arithmetic. This is not a common difference. But if we look at the second difference, we see that these numbers are arithmetic. So then we can rewrite it as 12 plus 8 plus 10 plus 12 plus 14. Then we identify the part that is arithmetic, and it can be represented by the sum is n a1 plus an over 2. So this series is 12 plus n times a1 plus an. Well, an is a1 plus n minus 1 times d. So a1 is 8, n minus 1, and then the common difference is 2. 16 plus 2n minus 2 over 2. Uh, 14 plus 2n over 2. And we get 7 plus n. And it's probably not the correct quadratic model yet, so we should go and test it. If n is 1, we get 20. If n is 2, we get 30. 1 goes to 20, but 1 is not supposed to go to 20. 2 is 20, 1 is 12. So we come to the same strategy that we did before, where we could say that 12 plus n minus 1, 7 plus n minus 1. And this simplifies to n squared plus 5n plus 6. So if we combine, distribute, and then combine the 12, we should end up with that quadratic model, which is also, we could just call that the nth term of that sequence. And that's the end of that video.